looks like that quiz went a little bit better. Right, that's good. But you had a big help the night before. Okay, so here's what I would like you guys to do right now. The ones that are circled on the board. I would like the formulas for all of those ones that are circled. Okay? Just on a piece of paper. These are also in your digital workbook if you're looking there. Okay, but like the formulas for all the ones that are circled, we'll go through those. Then we're going to do a few more that are the other way, where I give you the formula and you write the name. Let's see how we do when we don't have the kind of preparation beforehand and see how we do that. Okay? So working on those ones right now, please. So for our first one, is that ionic or molecular? It's ionic. We got a metal and a non-metal. All right, so I write the formula for the metal and its charge plus 1. Formula for the non-metal, its charge minus 2, and then I drop the swap them. 2, 1. Okay, and that's all there is to that. All right, for number 47, for manganese 2 oxide, what does the Roman numeral tell me about manganese? Its charge is 2, right. All right, so I'm going to have Mn with a 2 plus, okay, oxygen with a 2 minus. That already works out. So it's just MnO. Or I drop and swap, I get 2 2s and I reduce down to 1 and 1. Okay, whichever way makes more sense to you, as long as we end up with no numbers. All right, for number 49, another ionic compound, because mercury is a metal and it's got a Roman numeral, which we would only see in ionic compounds. So the mercury is the 2 plus variety, and it's with nitrogen, which is always a minus 3. So drop, swap. Okay, can't reduce those, so I leave them that way. Okay. And then for number 50, this one uses a little bit of everything that we've talked about to do with ionic compounds. It's got a Roman numeral, it's got a polyatomic ion, it's going to need brackets. Okay, so it's like the creme de la creme of the hardest ones you could get. Okay, so we got lead, which is Pb. The Roman numeral tells me this is the lead that's 2 plus. It's with hydroxide, polyatomic ion that's OH with a minus 1 charge. So the minus 1 goes here, and then the 2 goes outside of the brackets. And we would have that. PbOH in brackets 2. Okay, and then for number 52, we got selenium tetrafluoride. Okay, so that one is molecular because we got prefixes. So we got selenium, Se, with tetrafluoride. That's how many fluorides? 4. Okay, everybody all right with that one? What number did we get up to? I moved it up and then forgot which one. 56? Okay. So for number 53, we got phosphorus pentabromide. So again, it's 2 nonmetals. We see prefixes. That tells us it's molecular. So we got phosphorus, and it's got no prefix, so there's only one of it. Pentabromide means how many bromines? 5. And then number 55, we're back to ionic because we got a Roman numeral again. All right, we got nickel with a 2 plus charge with sulfate. That's SO4. Okay, polyatomic ion that also has a negative 2 charge. So these are already good the way they're written. So I could write it NiSO4, or I could write it NiSO4 in brackets, either way. Okay, and then our last one, silicon dioxide. Molecular, they're both nonmetals. Si, there's only one of it, O2. Okay, so the only way to really get better at these is to practice. Okay? I mean, if you're getting these pretty much every time, then you probably don't need a lot more practice. But if you're not getting at least 8 out of 10 on every 10 you do, then you need to keep practicing. Okay? The reason for that is we have to be able to write formulas and names so that we can move on to reactions. If we cannot get the formulas for compounds correct, then we will never get the reactions correct either, and it really snowballs after that. Okay, this is our fundamental skill for chemistry, so we really need to make sure we know how to do it. Right, now, there's a lot of worksheets on naming, yes? I have no intention of spending enough classes to get through them all. Okay, we don't have that kind of time. But I did include the keys in Google Classroom, so it is something you can do at home. And I honestly hope you don't have to do all of them, because it's a lot, okay? But they're there, if you want them or need them, okay? If it's something you're struggling with, then I would suggest you probably need to come in and see me, because there's probably some little thing that you're just missing, and we can probably fix it pretty quickly, okay, and get you back on track, okay? All right, I would like you now to try something to go the other way. There we go. All right, let's say verse 10 here. Oh, and the first one's easy. You can. When she comes back. Okay, let's have a look at these ones here. So, first one, it's pretty straightforward. We've seen that one so many times. So it's ionic because we got a metal and a non-metal. All right, so we write the name of the metal, sodium. We write the name of the non-metal, ending in ide, sodium chloride. Okay, and we do the same thing for the next one because it's also ionic. Potassium is a metal, so we write the name of the metal, unchanged. We write the name of the non-metal, ending in ide. So we'd have potassium fluoride. Okay, number 3, would that be ionic or molecular? Ionic, yeah. Lithium is a metal. All right, so we're going to have name of the metal and name of the non-metal, ending in ide. Okay, lithium iodide. What about number 4, ionic or molecular? Noah, ionic or molecular for number 4?
Say molecular.
That's a tricky one because it looks like carbon, but this is a metal, so it would be ionic. You got it. Okay, so calcium. Okay, write the name of the metal, unchanged, and then this stuff here. Polyatomic ion called sulfate. And we don't change the name of the polyatomic ions. Calcium sulfate. Okay. Number 5, ionic or molecular?
Ionic.
It's ionic. Aluminum is a metal. Okay, so we would write aluminum or aluminium if you want to put the extra I in. I don't. Okay. With bromine, so bromide. Okay, number 6. That one can be a little bit tricky. That one ionic or molecular? It's ionic. If hydrogen's listed first, it's behaving as a metal, right? Okay, so this would be hydrogen chloride. Okay, for number 7, we got a metal and a polyatomic ion. Okay, so we got another ionic compound. Lots of ionic ones on this list apparently. Okay, potassium, and what's OH called? Hydroxide. Would this be an acid or a base? It would be basic, yeah, because OH is the thing that's present in all strong bases. What about the one before it?
Acid.
Yeah, it'd be an acid. Okay, all acids are ionic compounds with hydrogen acting as the metal. Right, so that would be a strong acid, that would be a strong base. Okay, then we got carbon dioxide is the next one. Okay, that's one where we probably just knew what its name was just because we recognized it, but it's a molecular compound because they're both non-metals. Okay, number 9, ionic or molecular? It's ionic. hydrogen's listed first, acting as a metal, and it has a polyatomic ion, which is always an indication of an ionic compound. So this would be hydrogen nitrate. All right, and then number 10 was our last one. Also an ionic compound because we got metal and non-metal. Okay, that's just going to be potassium oxide. Okay, so other than having a couple in there that had polyatomic ions, those were all fairly straightforward, and none of them required what? Roman numerals. All right, so on that note, I'm going to find some that do. Except that there don't appear to be any in this list. Oh, there's some. All right, I would like you guys to do 27, 28, 29, 31, 33. Those 5. They don't all need Roman numerals. Some of them do. Not all of them. For right now, let's just put check marks beside the ones that need Roman numerals. Does number 27 need a Roman numeral? It doesn't. Okay. Does 28? Yes. Right. Does 29? No. Right. Does 31?
Yes.
Yep. Does 33?
Yes.
Yes. Okay, so our first one here for number 27, right, we got aluminum and oxygen, so we just go with our usual ionic naming rules, okay, aluminum oxide, right, no Roman numerals, no prefixes, okay, it's ionic compound. Now for 28, we've got lead, okay, lead does require a Roman numeral, and we got to figure out which one it is. So we look at sulfur, it's always a -2. They're here 1 to 1, so that means that the charge on lead must have been +2. Lead, Roman numeral 2, sulfide. Okay, everybody all right with that one? And then for zinc, this is one where I see people put a Roman numeral on it all the time, but it doesn't need it. Again, I'm not sure why that happens. It's just like far enough over on the periodic table, they just automatically assume. Okay, but it doesn't require it. Zinc is always a 2+. Okay, so zinc iodide. Now for number 31, mercury can be 1 or a 2. Okay, so I look to chlorine. There's a -1 charge on the chlorines. That gives me 2 negative charges. Okay, and so that means I need 2 positive charges from the mercury. So we're looking at mercury 2 chloride. Okay, and then we got tin with fluorine. Okay, fluorine's always a -1, and there are 4 of them, so that gives me 4 negative charges. There's only 1 tin to get the 4 positives from, so this is tin, Roman numeral 4, fluoride. Okay. All right, let's take about a 5-minute break here within the classroom, and then I'm gonna have you work on some trickier ones even. Okay, and then that'll kind of be it for today, I think. Mm-hmm. So first one's molecular, it's got 2 non-metals in it, so I'm gonna need prefixes. So that'll be dinitrogen, trichloride. Okay, what about our second one? Is that ionic or molecular?
Ionic.
It's ionic. Does it need a Roman numeral?
Yes.
Yes, it does. All right, so I've got to look at the non-metal here. Nitrogen's always a -3, and they're 1 to 1, so this must be the iron with the 3+ charge. So iron 3 nitride. Okay, and then for number 3, ionic or molecular on that one? It's ionic. Okay, calcium is a metal. All right, so we'll write the name of the write the name of the metal, and then we've got a polyatomic ion. So we write its name as it appears in the table of common polyatomic ions, calcium sulfate. All right, and number 4 is also ionic because beryllium is a metal. All right, so this will simply be beryllium bromide. Okay, number 7. Ionic or molecular? Ionic. Okay. What makes it challenging? It's got a Roman numeral and a polyatomic ion. It's got a little bit of everything. Okay, so I'm going to write the name of the metal, cobalt. I'm going to write the name of the polyatomic ion, nitrate. Then I'm going to figure out the Roman numeral after that. Nitrate is always a -1, and there are 2 nitrates. So there are 2 negative charges in total. There's only 1 cobalt to get the 2 positives from, so this is cobalt, Roman numeral 2, nitrate. Okay, number 9. Ionic or molecular? Caden, ionic or molecular? 9. That's a P. Phosphorus is non-metal. You're thinking potassium, I think. Yeah. Okay, so we got 2 non-metals. Phosphorus is non-metal, oxygen is a non-metal. Okay, so we don't need a prefix on phosphorus because there's only 1 of it. We don't put mono on the first one. Okay, and trioxide. Okay, number 11. Move 3. What are we looking at? Ionic or molecular? It's ionic, okay, because molybdenum is a metal. All right, so we got to look at what's the charge possibly on molybdenum, because I think it's going to need a Roman numeral, is it not? Okay, so there's 3 oxygens, each one's a -2. That gives me a total of 6 negatives. So this must be the molybdenum with the 6+ charge. Is that even a thing? It is. Oh, it only has a 6.
Yeah.
Sure, it used to have 4 and 6, but okay. So we don't need a Roman numeral. We just need to say this is molybdenum oxide. We have to change that. I'm sure that. It's a brand new periodic table this semester. I think they must have changed that. Okay, and then number 14. Moleculars. Selenium and bromine are both non-metals, and we can really get some work out with our prefixes here. All right, so 4 is tetra. So tetra selenium bromide. Okay, so that list would have had some of the more trickier ones on it. Okay, they won't get more difficult than that. All right, so to end it off, oh, I thought I had some that went the other way. I do, there they are. Okay, I would like you guys to write the formulas for the ones that I circle here. Those ones. have a look at these ones. So for number 43, we've got another ionic compound because aluminum is a metal, right? So I write the name of or the symbol for the metal and its charge, and the symbol for the non-metal and its charge. 3 and 3 already add up to 0. So there's my formula, ALN. All right, for number 44, okay, we got sulfur dioxide, molecular compound because they're both non-metals, SO2. Okay, and for number 45, ionic compound because we got a metal and a non-metal, cobalt with the 2+ charge because the Roman numeral tells us to. Okay, NO3 is a -1, so that one's going to need brackets with a 2 outside of the brackets. Okay, for number 50, we got copper 1 bromide, so Cu with the +1, Br with the -1, so that one's fine the way it's written. Okay, manganese 4 hydroxide, so that's Mn with a +4 charge, bonded to hydroxide, which is a -1, so when we drop and swap, we should get MnOH in brackets 4. Okay, and then lastly, we got diphosphorus hexachloride, so molecular compound, and that is going to be P2 hexa is 6, so Cl6. Do I reduce that one?
Yes.
Is it ionic? Then I don't reduce it. Okay, the prefixes told me those are the numbers. That's one of those rare things that sometimes comes up, which is why I picked it. Okay, on molecular compounds, the prefixes are absolute. We go with those numbers, we don't reduce. Because ionic compounds involve balancing charges, they can be reduced to their lowest terms and should be. All right, tomorrow we are going to go over the polar nature of water and solubility. It's a short lesson, it's a short class. Okay, and then on Monday we're going to get into reactions, right? And that is going to be like the next couple of weeks, right? So we'll get right into it.
It only has like a dash above it.
Yes.
Does that always always and then you put it down really fast.
Yeah, absolutely. Yeah, I'm not sure why they do that. That's the convention. Yeah.
I found that in my house at a random place. Actually, I had one, like 4 months. I lost it for 4 months. It wasn't.